take a look at number 1. We want to find the perimeter of a triangle with vertices -3, -2, -1, 3, and 6, -2. We want to leave our answers in exact and approximate form. So that means exact answers is the exact distance. Approximate is like when you plug in your calculator and round. So we need both. So what's going to be one helpful thing for us to do? What should we do with these points? Grab them. Plot them. Go ahead. Plot and label. So we have -3, -2. That's C. We have -1, 3. That is A. And we have 6, -2. That is our T. Oh, we're good one. And we need to find the perimeter. Well, how do you find the perimeter of any shape? What do you have to do with all the sides? Add them up. But in order to be able to add the sides up, we have to know how long they are. Right? We have to find the distance of all 3 sides and then add them up. It's really nice. These nice flat lines that are either vertical or horizontal, super easy to find their distance. All we have to do is what? We have a nice straight flat line. Yeah, it's very good, Grace. We just have to count. So we start at 1 point, we just count. How far do we go? 9. So the distance of CT is 9. Right, easy. Nice flat lines, whether they're horizontal or vertical. Count. Problem with the other 2, they are slanted. So when you have slanted lines, you just can't necessarily count them. Right? What do we say we use when they're slanted and we want to find the distance? Very good. We're using Pythagorean theorem. So you're going to make your right triangle. We're finding this side right here. Go ahead. Go up. Make your right triangle. What's the distance of this leg of your triangle? 5. What's the distance of this leg? 2. On those parts, and the segment you're trying to find is always your C. So those points are always going to be your A. So, and B. So we have the Pythagorean theorem. A squared plus B squared equals C squared. Now we have 5 squared plus 2 squared equals C squared. To save time, I just plug that in my calculator right away. If you want to break it down to an extra step, totally fine. Like you've been doing, let's save ourselves our time. What's 5 squared plus 4 squared? What is it? 10. Save yourself a step. 20. And then what do we have to do to both sides? Square root. Yeah, you can save time and just do it all in one step there. We've done a Pythagorean theorem enough to plug your calculator. If you need to break it down, if you don't have your calculator, then you can do that. If not, just do one step. Can we take the square root of 29? Oh, can we simplify 29? Oh, because we want exact answers, so whenever it says the word exact, that means you have to have your answer in simplest radical form. Can't simplify it, can't take the square root, so we just leave it as radical 29. That's the distance of that line. Right? We're going to repeat that same process with the other side. We want to find AT. Well, you just make your right triangle. Find the legs. What's that leg? Five. We count over. That one's 7. Again, plug in the Pythagorean theorem. A squared plus B squared equals C squared. Save yourself some time. Plug it in all in one step. 7 squared plus 5 squared is what? Four. Square root. Can we take the square root of 74? Can we simplify radical 74? as the square root of 74. Done. Okay? Yes.
That one won't split.
How will we know when we can just leave it?
There's no triangle. There's no perfect square that goes in.
If you can simplify it, you have to. If you can't simplify it, just leave it like that.
That is the exact.
You have to see if you can simplify first.
So your calculation is a long decimal. We don't need to round it. That's the exact answer.
I just misheard in the talk that
Yep. Square root, no square roots can go into 29, no square roots can go into 74. So,
We'll show you.
just leave
I
it.
have another example.
If a square root could go into it, then you have to simplify. So then, again, to find the perimeter, what do we do with all the sides? Add them up. So you take all three distances you found. So we take 9, we take radical 29, and you take radical 74. That's your exact answer. It's weird looking, I know, but that's your exact answer. Your approximate answer is what that is when you plug in your calculator. So you plug it in. 9 plus radical 29 plus radical 74. And you round to the nearest 10th as the direction set.
Hey, everyone should be trying this, especially borrowed calculators, because you can do this a different way.
Go backwards. For all calculators, you have to do 74. Green button x squared. Enter. Plus 29. Green button x squared. Enter. Plus 9. It's a lot messier. You go get your graphing calculator, your life's so much easier. Emma, what'd you get? What'd you get? Is that right? Yeah. What do we get? Well, when you plug it in, it's a little goofy. You get 22.98 when you plug your calculator. If you did not get that, check how you plugged it in. Okay. So because you're rounding to the nearest 10th, this 8 bumps that 9 up to a 10. So that became 0. Then that 1 carries over, so 22 becomes 23. You have to have that decimal point there to show that you rounded. Yes.
I'll show you guys. I'll come around and say.
Questions over that? Any questions? Alright. We take a look at 2. You need to find the area of a rectangle.
It's 74. What? Oh, I did wrong. Yes. No, because that would not be the exact answer. It would start rounding. That one might work out. It doesn't work all the time. I'll show you in a second. We're going to practice that. Just put a little star next to it. I'll show you afterwards. Okay, number 2. Again, we'll have time. We should have time to get a class. We'll answer some questions in thorough detail if Miss Baker's floating around right now. So, number 2. Find the area of a rectangle with the vertices. That. Leave your answer in exact and approximate form. Round your answers to the nearest 10. Okay, first thing first. I've got a grid. I've got some points. I need to put them on the grid. That's a good idea. I would do the same thing. So when I go through, graph them out. It's going to be negative 6, 3. Negative 6, 3. Right there. That's T. U is 0, 6. U. X is 2, 2. And then Y is negative 4, negative 1. Y. I know it's a rectangle because it tells me it's a rectangle. There we go. There's my rectangle. Now, we're asked to find the area. How do you find area of a rectangle? And you guys all know this formula back from your childhood. Close. Double that. Base times height, very good, very elaborate and slow process there. But yes, the formula for area of a rectangle is base times height. Very good. So we're going to do that. But what's the problem with this? They're not, yeah, they're not exactly. We can't count. Like you over here, we had CT who was on a horizontal line. You can easily count that. There's other ones we have, but here, there's nothing on a horizontal or vertical line. So we cannot count. But I do need that base and that height. How do I find it? Our old friend, Pythagorean theorem again. So what I'm going to do is look at the bases. It doesn't really matter. Just pick two sides that are not opposite. I'm going to say TU. I'm going to find that one first. So I'm going to, again, make my little triangle go from TU. Almost like, kind of like I'm doing the slope a little bit there. So I'm going to find the distance of TU. And again, we're going to use that Pythagorean theorem. Let's count, figure out what that distance is. 1, 2, 3. Got it. The other one up here. 1, 2, 3, 4, 5, 6. Got it. Well, just like you've been discovering, every time we do this using Pythagorean theorem, that segment is the C value. The other two are A and B. It doesn't matter which one you use. So I'm going to say, or which one's A or B, I should say. 3 squared plus 6 squared is equal to C squared. All right, let's simplify this a little bit. 3 squared is 9. Plus 6 squared is 36. It's equal to C squared. 9 and 36 gives me this number. 4, 5 equals C squared. You know what to do next? Square root, square root. 45 perfect square. No, but I still need my exact answer. Jason, you had a question like this a second ago. Is there a number, is there a perfect square that goes into it? What perfect square goes into it? 9 does. So what I do so is square root of 9 times what? 5. Square root of 9 times 5. Very good. Got it. Well, that breaks down, so I know that C is going to be equal to, what's the square root of 9? 3. Square root of 15, or 5, doesn't happen, still 5. So that distance right there is 3 radical 5. Okay, not very nice as a roll off the tongue, but still, it's going to help us solve here. Well, that is one of the bases. Let's find the height. So we need to pick another side that is not opposite of TU. What segment do you guys want to find next? Jacob, what do you want to find? Because I'm asking you. I don't know why you chose it. Why? Oh, TY. I get it. You're talking about a segment. So, right, he said he wanted to find TY. So, I'm going to have to go down and over. And we're looking at TY. All right, well, how far did I go down for TY? 1, 2, 3, 4. That's going to be one of my sides, plus the other one I went over how many? 2. Squared equals, and we know we're going to find that C squared. Simplify a little. 4 squared is, great game, plus 2 squared is, 16 and 4 gives me a, how do I get rid of this? Again, same process, square root, square root. 20 is not a perfect square, but is there a perfect square that goes to 20? 4 does. So it's going to break down to this, 4 times radical 5. So my C value is 2 radical 5. There it is. So I now have my base, and I have a height. So I need to figure out the area. You guys told me area is base times height. So what do you think I do with these two numbers? Multiply them together. So once again, area equals base times height. We'll get more on that later. So when I do that, I know the area is going to equal, one of my bases was 3 radical 5. The other one was 2 radical 5. And we're going to go ahead and solve. Well, real easy. The number in front, it's real easy to multiply. What's 3 times 2? 6, I agree. So multiply these like numbers with 6. What's radical 5 times radical 5? What is it? Radical 5, you're close, you're very close. Not radical 5. What? It's just 5. Because remember, what's radical 5 times radical 5? We've done this before with simplifying it. 5 times 5 is 25, but there's a radical above it. So it really is 6 radical 25. Or square root of 25. What's the square root of 25? 5. So this really is 6 times, this is what you were saying with a shortcut, this is really 6 times 5. Remember we told you that shortcut where we're simplifying radicals? That's why we showed you the shortcut, but the long way is you have to multiply the top and the bottom by the radical, and then we know the radicals or the radicands are the same, then they cancel out. So this just becomes 5. So our last step is, the area is what? What's 6 times 5? 30. That's it. Good. Questions on that? Again, you'll start doing this. We're doing more and more things, but we just basically have to use Pythagorean theorem. It's one thing we're using a lot. Okay. What about this guy? Number 3. Well, we found area of a rectangle. Let's find the area of a triangle. Who remembers the formula for area of a triangle? Now here comes that half. We know the formula for a triangle is area equals 1/2 base times height. Why is that? It's because when I think about if I had a triangle, well, I'll show you why it is in a second, but once I graph this out. Next, let's graph out these points. -4, 4. -4, 4. 6, -8. 6, -8. The other one is 6, 4. And let's connect our sides. And there it is. Now, some of you are saying, oh, why is it 1/2 base times height? That's a triangle, right? We agree that's a triangle. 3 sides are connected, yeah, it's a triangle. Watch what happens. Don't do this, just watch what happens. But if I connect the side, what did I just make? Well, a rectangle for sure. I made a rectangle. And how do you find the area of that? It's base times height, right? Well, if I just look at the black part, isn't that half of that rectangle? That's why it's 1/2 base times height. Because a triangle really is just half of that figure. So there they are. Let's go ahead. We're going to do the same thing. But here's what's nice about this one. Can I easily figure out some of the sides? Yeah, because they're on either vertical or horizontal line. And all we need to do is count. Because I automatically have my base, my height, this one. Let's just count the sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The other one over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 there. That. So, do Pythagorean theorem? No, you don't need to. All I need is the base. Got it. It might not be 15. I know you're trying to do, I think it's 15. This side the diagonal. Would not. So what I need to do is just simply plug it into the area formula. It's a 5, 12, 13. That one's not. This isn't a P-trip. That's what you're asking. Because it's not. 5, 12, 13 is one. And then 3, 4, 5 is not 3, 4, 5. You can't just make up P-trips. Oh, the 37, 9, 2, 8. You're straight P-tripping right now. Okay, so we don't need to do Pythagorean theorem here because I have my base and my height. We just have to plug in the formula. So the area equals 1/2. Give me one of the bases. It doesn't matter. Which one do you want to use? Okay, so I'm saying the base is that. It's oriented on the top. So I'm going to do 10 times. What's the height? If the base is 10, what's the height? 12. And we go ahead and solve. We simplify. Use calculator, not calculator. I don't care. What's half of 10? 5 times 12. What's 5 times 12? 60. So the area does equal 60 units. Units. Do you get marked off of that? No, but there's times later down the road you're going to have units. I'm helping you for science. Because if you don't do it in science, then we'll see you next year.
We flip it over to the back. On the back, figures are already drawn for you. You just have to use them to find, in number 4, the perimeter. Again, just like that first problem, to find the perimeter, you have to add up all the sides. Add up all the sides, you have to find the distance. What do we use to find the distance in the coordinate plane? Pythagorean theorem. So you're going to be doing the Pythagorean theorem a bunch of times because none of our lines are nice and straight and flat. None of them go up and down perfectly. None of them go horizontally perfectly. They're slanted. So just pick any side. Doesn't matter. I'm going to pick DX or AD. We're going to find that distance first. Again, when you find distance, we use the Pythagorean theorem. We're going to find this guy first. Oh, make your right triangle. Up and over. Count your legs. What's the distance of this leg? Can we count? What do we get?
Leave yourself some room to work as well.
Yep, 12. So this guy's 12. What's the distance of this one? 5. So there's those legs of the triangle. Again, we're always finding our C. So you just plug it in. 12 squared plus 5 squared equals C squared. If you need to break it down more, that's fine. Save yourself some room and time. Just plug your calculator. 12 squared plus 5 squared is what? 169. What do we have to do to both sides? The root, and again, if you recognize this is a p-trip, because what's the square root of 169? 13. So there's our 5, 12, 13. If you don't recognize it's a p-trip, not the end of the world. Pythagorean theorem. There's the distance of that one. Repeat the same process for all the other sides. Let's find this side next. AB. So make your right triangle. Count your legs. Use it to count. This one's 2. And this one is what? 6. Okay. Well, let's find AB next. Plug those legs in the Pythagorean theorem. 2 squared plus 6 squared. What's 2 squared plus 6 squared? 40. It's really nice. We just want to know the approximate. It did not mention anything about exact answers. It just says round. So we don't have to worry about simplifying our radicals. If it said exact, you would need to. It doesn't. So we're just going to leave it as radical 40 for right now. You don't have to simplify. Don't round yet. Round at the very end. Okay. Repeat the same process for this next line. We're going to find BC. Make your right triangle. Count your legs. What's the distance of this leg? What's the distance of this leg? Plug in Pythagorean theorem.
I wonder why there isn't a symbol for that.
What do we do? We do 7 squared plus 17 squared? 338.
Oh, so it's like this.
Yeah, it's across.
Square root. Square root. Again, 338 a perfect square. No, just leave it. Don't round. Save it for the very end around so your answer is precise as possible. And then you do the same thing for the last one. I know it's like, OMG, I'm tired of doing Pythagorean here. Easy stuff though. We all know how to do it. Gotta do it a bunch of times. So, I'm finding this triangle. Make your right triangle. Count. What's the distance of that side? 3. What's the distance of this long side? 19. Again, plug in your Pythagorean theorem. 3 squared plus 19 squared equals c squared. Save yourself some time. Plug your calculator all in one step. What do we get? Okay. So when we do 3 squared plus 18 squared, what do we get? 333. Again, square root both sides. We don't. Is 333 a perfect square? No. We'll just leave it. If it said exact, then we have to look to simplify. It doesn't say exact. Usually not the radical. So again, to find the perimeter, you take the distance of all the sides and you add them. 13 plus radical 40 plus radical 338 plus radical 333. Plug in your calculator. What do we get?
Borrow calc, have to go backwards on it.
Yep. Our calculator is 333. Green button x squared plus 338. Green button x squared plus 40. Green button x squared plus 13. Life is so much easier if you have a graph calculator. Lexi, what'd you get? So you have 55.95. So when you round to the nearest 10, again that 5 bumps it up to a 10. The 1 carries over, so it becomes a 56. Done.
Someone's going to say, do I need that 0 there? Yes, you do. If that 0 is not there, you were telling us the exact answer is 56. That 0 tells us you rounded. So without that, you are wrong. You need that 0 there. That's what the little squiggly means. Approximately that answer. Questions on that? Exact answer, estimated answer, approximate answer. All right, well, we just did a quadrilateral. Let's move on to a trilateral. What's a trilateral? It's a good thing to call it. All right, so here we go. We want to find the area of the following triangle. Round your final answer to the nearest 10. All right, no exact answer needed for this guy. What do we do? All right, well, we do exactly what we did back here, right? Area of that one, real nice and easy. But what's the problem? They're not. Is anyone on straight lines? If one was on a straight line, we could do it. We could figure it out. But none of these lines are straight lines. So what do we do? Well, here's what we're going to do. We are going to, good guess, no, wrong. That's going to be the formula. That's the area formula. We'll be that. It's going to be area equals 1/2 base times height, indeed. But here's what we're going to have to do that. What I'm going to do is I'm going to enclose this triangle inside of a rectangle. What? Yeah, that's what I'm going to do. I'm going to connect all the dots so I made a giant rectangle that houses that red triangle. I'll show you. Here, it's coming at you. Get ready. So I'm going to take this. I'm going to switch it up a little bit. We go highlighters on you. So I'm going to go across. Get down. Oh, that second one did not turn out as straight as I like it to be. There we go. There's one side of it. Now let's go down here. This side. Thank you. I chose it. There's another one. The last one. Oh no. Just a little guy. But if you notice, what did I really just do? I enclosed the triangle, so it's no longer a triangle, it's now a quadrilateral. But I also just made 3 new triangles. Eric, see him? The maroon, the blue, and the green. Well, here's what I do. This is the process I need to do. First thing first, I need to find the area of this quadrilateral I just made. How do I do it? Well, good news is you guys just figured out how to do quadrilateral, or a rectangle. Parallelogram, how do you want to think about it? So I'm going to do the base times height once again. Base times height, indeed. So I'm going to go to count, figure out how long this segment is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 17. That is 17. All right, so that section is 17. Well, let's go over here to the green side, because that's all one side there. How long is that? You're going to say 17, you're wrong. Because it's not really a square. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 is 15. Don't count where you started. All right, so it's 15. Great. Let's find the area of this big shape. So I'm going to say area equals base times height. So 17 times 15. What is 17 times 15? It is this number that has a couple other numbers with it. 255. So the area of the whole shape is 255. Question, Jason?
Yeah, why wouldn't you use the base and the height of the triangle itself?
Because there's nothing on a straight line. Over here, AD is on an angle, so I can't count how long that is.
But
if it was, I would be able to.
Wouldn't you be able to through a squared plus b squared equals c squared?
That would tell me what it is, but then I wouldn't know how. I'd have to figure out what that segment is. I'd have to find how long that piece is. It just makes a lot more work.
But I don't understand how the half thing works. Isn't it like the reason the half thing works is that if you copied the triangle and then put it in half, it would make a quadrilateral.
And that's what it is over here. Yes, it went there and made a quadrilateral. Yep. That's why it's half.
But the dimensions of a quadrilateral that would completely surround it would be different than a one that would.
That is why that formula will not work, because that deals with the diagonals. If this point was up 3 more points, I could easily do that, and I would use that formula. But because it's not, and none of those are on straight lines, and if it was, that would make that a straight line, I'd have to do it this way.
No, I was saying like the one you're doing right now, I'm confused how that works.
Well, let's keep watching here. We'll show you this one. What we're trying to do is we're trying to find the area of the one in here. So if I make it out of a rectangle, all I have to do is figure out the area of this piece, figure out the area of this piece, figure out the area of that piece, and get rid of them from the whole thing. And I have how big that is, how much space it occupies. Because just like what he says, that would have to be the diagonal. I'll show you why. This is half. Both these triangles are congruent. They're equal. That's why it's divided by half. If I cut in half with a diagonal, it makes 2 equal triangles. Remember a triangle congruent stuff? This is a triangle formula. What we did is we found the quadrilateral first. Okay?
So no time we just
Nope, we are, because now we have 3 triangles that we're going to get rid of from the original one. We'll show you. So, now, let's find area of this guy. We said this is 17. How far is that piece? 1, 2, 3. So that one's 3. So now we're going to do the formula for area of that triangle. You'll see why we do it here in a second. So if I do area of this triangle, how long is one of the bases? Of this, the purple one. Give me one of the bases. Any base at all. 3. Okay, good. But I need my 1/2. Got my 1/2 in there. So it's going to be 1/2, because now we're using it because it's a triangle now, it's not a quadrilateral. 1/2, 3 times 17 is the other one. And now you can use your calculators. What's 1/2 3 times 17? $25.5. 25.5. Decimals are okay here. 25.5, because our answer is going to be in decimal form. So that one's 25.5. I like to write them in there, just see what I'm doing. So that area is 25.5. Well, let's go on to the blue section. Let's label that piece. Well, how far is that section? Well, use your head a little bit here. If this is 3, and this side's 15, what's that section have to be? 12. What's 12 plus that? There. Over here, a little tricky about the same thing. Whole thing 17. How long is this one? 16, because there is a little guy right there. So it is 16. This guy's 1. All right. Well, now we have the sides of it. Let's go. So the area equals 1/2. Give me one of the bases of the blue one. All right, cool. 16 times 12. That will equal something. 8 times 12 or 16 times 6, however you want to do it. Just have your calculator. 1/2 16 times 12 gives me this number. Calculate. Sydney, thank you for volunteering. 96. Too enthusiastic for my taste. And the last one is going to be the green one. Everything's labeled already, so we're fine. Again, it's going to be areas 1/2. Give me one of the bases. 1. Not good. What's the other one? 1/2 1 times 15. 7.5. So you're saying, why do we do all of this work? It's because I want to figure out what that one triangle is. There's not a great way of doing it. And you could do Pythagorean theorem to find the distance. We got to figure out what that straight line point is. You have to figure out making a right triangle. It's a lot of work doing that because you have to make this line perpendicular to find the point. So not a great way of doing it. But if you make it a rectangle, I know how to find the area of a rectangle, base times height. And if I get rid of those other pieces, the blue, the purple, and the green, guess what's left? If I get rid of those pieces, what's left? The area of the triangle that I want. So what I'm going to do is, I'm going to take, let's go a little too green action here, I'm going to be pretty green in a while. I'm going to take the whole thing, which is 255. That's the whole rectangle. I'm going to subtract 25.5. I'm going to subtract 96. I'm going to subtract 7.5, and that will give me my answer once I round it. So when I subtract all those things, what will be my area of this shape, of that triangle inside? So this is 96. So this is 7.5 right there. So that area of that triangle that is inscribed there is 100, approximately 126. Exactly. Let me use exactly 126. I just put units there. You don't need units there.
Have you ever had somebody try to like count squares?
That's how many there are. 126.